Hi guys, good afternoon. Thank you very much for watching my videos. Please check out the PIC16F684 playlist on my channel for more videos. And please subscribe. Go ahead. Okay, thank you very much. So in a moment I'll get to covering the code I created, but I think it's easier if I start with this circuit diagram. So the point of my code, and I'll get to that, the point of my code is to show how two input pins, RC and R3, RC3 and RC4, can be used as an AND gate. And the C equivalent code perhaps demonstrates it the best. If RC3 equals 1, if it's high, and RC4 equals 1, then send RC2 high. And maybe it needs an else if statement, because otherwise RC2 should be low. So if RC3 receives a high and this switch is closed, and RC4 receives a high and this switch is closed, and they both have to be closed, only then will RC2 go high. Otherwise it's set low. I kind of already explained it, but in this circuit there are two inputs, RC3 and RC4, and they are configured that way, and RC2 is the only output. Alright, I'll be moving over to explaining my code, and just in case there's somebody who's at the very beginner stage, I'll try to explain a few other things like bank switching. So bear with me. Actually, before I explain my code, I'll just touch upon some relevant things for the sake of learning. So when you look at the pinouts on the chip, you'll notice that these pins can be multiplexed, or they can be used for different purposes. So the pins I'm using today are RC2, RC3, and RC4. But those pins, you can see, have other functions. You can use these pins for like the comparators, and you can set it up according to, you know, the inverting and non-inverting input and all that stuff if you want to make use of the comparators. But you can also set the pins up as analog pins. So say you set an output pin as analog, you could maybe output varying voltage levels. Likewise, if you have an input pin set up as an analog pin, you could maybe detect and convert those analog values into digital values. And that's a discussion for another day, but that's why you might want to do that. But in making use of your chip, and especially for today's purposes, we don't want to configure the pins as analog pins. We want all the pins to be configured as digital. There is more that could be said about the ANSL register, but I won't cover that today. But we don't want to use our pins as analog pins. So we want to set all of these bits to 0, or we want to clear these bits. And clearing them will make them digital pins. And they will configure those pins that are multiplexed with those different functions. It'll configure them as digital pins. Another thing that is important with the PIC16F684, and something that's important to know, is that in the RAM, or the data memory map of the PIC16F684, it has two banks, bank 0 and bank 1. And to write to and read from and access the different special function registers, all these registers with a specific name attached to them, those are special function registers, or SFRs, that's opposed to GPRs, which are blank volatile memory space that you can write to. But anyway, if you want to access these special function registers, or even these general purpose registers, you have to select the correct bank, bank 0 and bank 1. If you go to the datasheet page, page 13, on the status register, you will notice that bit 5 is the bank select bit. So you have to toggle this bit on and off if you want to access those different file registers. I mention that because to set up the chip, you will need to toggle that RP0 status register bit. And that is because the trice registers, trice C and trice A, which pertain to port A and port C, are contained within bank 1. Also, the ANSL register is contained in bank 1 as opposed to bank 0. So I'll get to that in my code, but you will see that that RP0 bit has to be set or cleared. Okay, now I think it's time to explain the code. So at the top I gave it a title. I included the applicable library for my particular chip, the PIC16F684. Then I created some defines. They're a little bit like creating variable labels, but maybe there's a better explanation than the one I'm giving. But I set these variable names, for lack of a better term, to the pinout values of the chip. So then when I make mention of them in my code, it's really referring to, in this case, port C pin 2. So anyway, I configure the chip. You might do it a little differently. I think you can use the other internal oscillator choice. You might not do it exactly like I've done. I like to turn almost everything off. You could have the power up timer on. It's important to have the watchdog timer off without explaining. Okay, so I start the program at 0x00. Sometimes if you want an interrupt service routine, you won't start the code here. You'll start it a few lines later. But anyway, I initialize the chip by doing a BSF, bit set F, the status register RP0. That, I'll leave a comment. Okay, I left 2 comments. So I set RP0 to a high, and this will select bank 1 in the file register. because all of these things are accessed in bank 1 of the register. And when I'm finished, I clear RP0 in the status register, and this will select bank 0. And the rest of the program only uses what's contained in bank 0. But you have to set the status RP0 bit. Anyway, because we're in bank 1 now, I clear ANSL, which is the analog select register, and this sets all the GPIO pins on the chip as digital, and we're not making use of the analog functions on those pins. And what I've done here is I've set all of the pins as input except for RC2, which I've configured as an output. You might think of the number 1 as similar to the letter I, which stands for input, and 0, which is similar to the letter O, which stands for output. That's how many textbooks teach that. And anyway, once we've have the corresponding bits set, we move that value into the trace C register. So this is bit 0, bit 1, bit 2, 3, 4, 5. There's only 6 pins in port C. So now RC4 and RC3 are inputs, RC2 is set as an output, and they are all digital. Now we're going to bit test RC4, and I called it RC4 in because it's an input pin, and we're going to check and see if RC4 is low. Actually, this should be high, and this should be high. We are checking to see if it is set, and RC4 input pin is set. We skip the next line if it's set, so we skip this line, and then we do a bit test file skip if set on RC3 input pin. If this pin is set, then we skip the next line if it is set, and then we set RC2, which is an output pin, and we set it high. And then we go back to the loop and check to see if those buttons are being pressed for a high signal on the inputs. Only when RC4 and RC3 are high will it set RC2 high. So that's why I'm calling this a logic AND gate. If RC4 and RC3 are high, then RC2 also goes high. But if one of the pins is low, then it will break into this routine and it will clear RC2. In fact, in the resting state, the way my circuit is set up, RC2 is low. But I will be methodical and go through giving an example of that. So, if we go back to the top of the loop and we bit test the file and skip if it's set, and in fact RC4 is receiving a low signal and it's not set, it won't skip the next line. It'll go to the next line, which is a go to command, and it says to go to not set. So if RC4 is getting a low, it won't skip the next line, it'll go to it, and in this case it's a go to instruction to go to the not set loop, which will clear RC2 and send it back up to the loop. If RC4 is high, sure, it'll skip this line and go to the next one. But if RC3 is receiving a low input, it won't skip the next line, it'll go to it, and in this case it's go to, not set, so it'll break out of this loop and it'll clear RC2, and it'll break out of this loop and go back and check. And not until RC4 and RC3 are both high will it then set RC2 high also, which again is an output pin. And it's all controlled by my fingers. So you'll see that in my circuit setup and experimentation. I have a popsicle stick module which has like a debounced switch module in it. I made a video on my channel. You can look for that if you want to see why I'm using such a big elaborate device for a debounced switch, but it works well. And then I just have a little fun at the end of this video, and I hook RC4 and RC3 up to two different blink circuits. One is a 555 timer and another one is something very, very similar, and they both blink at different rates, and because they're both blinking at different rates, they're on at different times, and it kind of gives RC2 an erratic output, and just for fun. So hopefully this helps you. Maybe it's too much explanation, but if you're a beginner, maybe it's helpful. Well, thank you very much. It's been a simple little project. I've had fun this afternoon setting it up, and I hope to do more sophisticated things. But thanks for watching, and don't forget to subscribe. And maybe like the video if you thought it was good. Thanks. Have a good day, guys. Take it easy.
Good afternoon. It's hard to really see what's what, but this green line is RC4, the orange line is RC3, and the blue line is RC2. RC4 and RC3 are inputs. RC2 is an output. It's set up to function like an AND gate, so when RC4 and RC3 receive high inputs, when both of them are ANDed together, and only then, RC2 as an output will send out a high. But it can't be just one of them or the other. It's not an OR gate, it's an AND gate. So both RC4 and RC3 have to receive high inputs. And trust me, they're doing that. So the RC3 is hooked up to a low currently, and the RC2 is currently hooked up to a low, even though it's hard to see. I'll take the light away to see it better. Pushing one, pushing the other. RC2 is doing nothing. But when I push both of them, RC2 goes on. Well, I thought I would have a little bit of fun. So I hooked up RC4 to this type of 555 timer circuit. It's not exactly a 555, but it does a blink routine. This is a 555, and RC3 is hooked up to this 555. RC4 is hooked up to this, RC3 is hooked up to this, They both blink at different rates, and RC2 blinks when they're both high. This circuit is adjustable.
Taking a picture of some fish. Ooh! Taking a picture of some fish. Ah! Taking a picture of some fish. Woo! Taking a picture of some fish. Wow! Smelly stink fish. Yeah, I'm taking a picture. I'm gonna show my mom. Snapping a shot of a fish. Blub, blub, blub. This fish ain't making no bubbles. The fish is wrapped in